Welcome to Speed and Velocity. For some background information on this video, you might want to watch the distance and displacement video. If you don't, you should be fine. The unit is more or less self-contained and you should have no problems following what's going on. We're going to start with speed. And number one, speed is a scalar. Speed has magnitude only. And from your work on vectors and scalars, you know that's the definition of a scalar, magnitude only. Speed is distance divided by time. And speed has units of distance over time. Examples of some units for speed are meters per second, kilometers per hour, feet per second, miles per hour. These are the most common units you're going to use. You're going to run into things such as centimeters per minute and so forth, all entirely legitimate speed units, but these are the four most common ones. And how do we calculate velocity? We simply use the equation v is equal to s divided by t, where v is the speed, s is the distance, and t is the time. Let's move on to velocity. Velocity is a vector, which means velocity has magnitude and direction. A quantity with a magnitude and direction is a definition of a vector. Velocity is displacement divided by time. Remember, displacement is a straight line distance between the starting and the end point. It does not take into account the path taken. It is only the straight line distance between the start and the end point. Velocity has units of displacement over time. And some examples of displacement units would be meters per second east, kilometers per hour south, feet per second northeast, miles per hour west. Now, this looks an awful lot like speed with a direction added. That is incorrect. Velocity is displacement divided by time. Speed is distance divided by time. Speed takes into account the path taken. Displacement only takes into account the straight line distance, and so velocity is only concerned with the straight line distance from the start to the end point. Lastly, the equation itself is a velocity vector is equal to the displacement vector divided by time. Okay, now let's work an example. Here we have one where a biker rides 20 kilometers south and then 99 kilometers west. The whole trip takes 10 hours. Find his speed and velocity. To work the problem, I drew a little diagram. And we see the 20 kilometer south leg, 99 kilometer west leg, and the hypotenuse of the right triangle is the magnitude of the displacement. I also chose this angle right here, theta, as my reference angle. So in the end, I'm going to say that the biker ends up so many degrees in a direction west of south, I mean this direction right here. Okay, first of all, let's calculate his speed. Well, speed is nothing more than distance divided by time. And the distance traveled is how far he actually goes. So he goes 20 south, 99 west, and I divide that by the time. So I have 119 kilometers traveled in 10 hours, which gives me a speed of 11.9 kilometers per hour. Pretty straightforward, nothing mystical there. Now, let's calculate the velocity of this biker. We need to find the magnitude of the displacement s, so I'm using the Pythagorean theorem because I have a right triangle. 20 kilometers squared plus 99 kilometers squared. I do the arithmetic and I find his displacement is 110 kilometers, or at least the magnitude of the displacement is 110 kilometers. Now, how do I find that angle theta? Well, I say the tangent of theta is the opposite of the adjacent, and according to our triangle, the opposite is 99 kilometers. The adjacent is 20 kilometers. So when I solve for theta, I find it's the inverse tangent or the arctangent, both mean the same thing, of 99 kilometers divided by 20 kilometers. I put that in my calculator and I find that the angle theta has a magnitude of 79 degrees. So my velocity vector is my displacement vector divided by time. Here is my displacement divided by the amount of time, 10 hours. And here is my direction, 79 degrees west of south. So when I finish off the whole thing, I say I have a velocity of 10.1 kilometers per hour and an angle of 79 degrees west of south. Here's a practice problem. My suggestion is after you read the problem, you stop the video, work the problem, and then compare your answer to the one provided in the video. I'm going to give you a little heads up right now. This is something of a trick question. It's different from the example given because you need to calculate a couple different values. A boy walks 9 meters north and then east. Notice you're not told how far east the boy walks. He's displaced 41 meters from his starting point. If the whole trip took 70 seconds, find his speed and velocity. All right, so go ahead, work the problem. Here's another hint. Draw a diagram, and then compare your answer to what's provided on the video. Okay, I hope you worked the problem and just then go ahead and read the solution. Drew the diagram, 9 meters north, some unknown distance x to the east, displacement of 41 meters. Now, I need to find how big x is. So I use the Pythagorean theorem, and I do all the arithmetic, and I end up with 40 meters. So the boy walked 9 meters north, 40 meters east. So to find the speed, I need nothing more than the distance divided by time. The distance walked is 9 meters plus 40 meters, and the time is 70 seconds. And it gives me a result of 0.7 meters per second for speed. Now, how do I calculate the velocity? The velocity vector is the displacement vector divided by time. This right here stands for the magnitude of the velocity vector. The vertical lines or absolute value sign means the magnitude of the vector inside. Well, I know the displacement was 40 meters, that was given, and the time was 70 seconds, also given. Gives me the magnitude of my velocity as 0.6 meters per second. Now to calculate my theta, my reference angle, I'm going to use the cosine, which is the opposite over the hypotenuse. 9 meters divided by 41 meters. Using my calculator and the inverse cosine or the arc cosine function, I get theta is equal to 77 degrees. So I put those two together and I say that my velocity vector is 0.6 meters at an angle of 77 degrees east of north. Okay, I hope that helped. Please feel free to leave a comment. It really helps me. Anything you'd like to see added or subtracted or it wasn't clear, please let me know. And I'm waiting to hear from you.